Hello everybody and welcome to this YouTube video, and today we're going to talk about the important concept which is a bias and variance, and also welcoming you to Enter the Machine Learning course. And in this video we'll talk about the bias and variance, which is important, but in this series of machine learning we're not going to go deep dive into our bias and variance trade-off. We'll be going deep dive into bias and variance in the deep learning course, which will be uploaded soon. Okay, so we will not go into deep dive, but I will give you the overview, and we'll fix that we have talked about and we will choose what solution is best for what conditions. Okay, so first of all, let's see when we say we have a high variance or a high bias. So first of all, these are my xy plane, x and y plane, and these are some of my data points. And if our model unable to generalize well on this data, it simply means that it forms a line, something like that. And you can see here, this is very bad model, Why? Because it unable to generalize well on our training data. So that's why we call it as an underfitting. That I'm just recapitulating about 3 times or 4 times I recapitulated this, so I think this would be very clear to you. And if we say our model is underfitting, we can say that it has high bias. Okay, and in case of overfitting, we say that high variance. So what is that? Let's say again we have a data points. We have something like a cross sign of data points, and if I plot our hypothesis, it will something like this. Okay, it will something like this. And what is it? It's generalized as well on our training data, or I can say mtrain, and it fails to generalize well on our testing data. Okay, so and in case of overfitting, we can say our model has high variance. And note here is that we will not go in deeper into the bias and variance trade-off. We'll explore this bias and variance trade-off in our deep learning course. As in machine learning, this will be very difficult to you to understand this, all the kind of stuffs like learning curves, etc. There are lots of bias and variance trade-offs, etc. We'll learn more about the machine learning, and then in the deep learning course we'll explore these. Okay, if I talk about the whole bias and variance trade-off here, you will not get a single penny of knowledge from that. So that's why I will be covering that in a deep learning course. Okay, that I've talked about the high variance. When we call the high variance, is that when our model is overfitting. We call a high bias when our model is not performing well on training data, as well as not performing well on a testing data, which is a underfitting. So the first solution in the first video of this section, and the debugging our machine learning model, the link will be in the description box below. Be sure to check it out. And we have talked about some of the solutions that can prevent us from overfitting, that can fix our issue of overfitting and underfitting. Okay, so and I had given a pause there that we don't choose these solutions randomly. We have to take a look what solution, and when we implement the solution, what solution that fixes up. And this might feel statement confusing. So let's go on to the first, and I will explain just now. We have talked about getting more training examples. Here M is the training examples. Okay, and it fixes what? It fixes high variance. It means overfitting. And now I had talked about if we get more training examples, it fixes our overfitting if our model is overfitting. Okay, and I've given up in the first video pass because let's say our model is underfitting, and we choose the solution, this first one means getting more twin examples. Does it getting more twin examples fix overfitting? But if we take this solution and plug that in, do it will fix underfitting? No, absolutely no, because it only fixes overfitting, not underfitting. So that's why I've given a pass, because we don't choose the solutions randomly. We will explore what solution fixes what condition. Like getting more twin examples fixes the overfitting. We'll talk about what fixes the underfitting. Okay, this might seem so very easy to you, and I had talked about the why I've given pass there. Trying smaller sets of features. It simply means we remove, there are lots of like a number of, for the price of the house, we eliminate the features that are not important. If we do not eliminate the features, they form a curve like a structure, and that cause overfitting. Okay, and that cause overfitting. By getting small sets, by eliminating our features, we will fix our issue of overfitting. We have talked about how to fix overfitting. We have talked about the getting more training examples and trying a smaller sets of features. Okay, now, and also we can, if we add features, what causes underfitting? First, let's answer what causes underfitting. I had talked about that if we have a small sets of features, that causes our underfitting. So if we it's small, then we can add various features. Then it will fix our issue of underfitting. And again, if I pull out this adding features and fit, if our model is overfitting and I add more features, then it will prone to more and more overfitting, and that solution will never work. Okay, so that was adding features. If adding features, it fixes our high bias, that is underfitting. I talked about one solution of the underfitting if our model is underfitting. Okay, now if we decrease lambda, what is help, and increase lambda. So let's talk about this. If we decrease our lambda, it helps us to fix the issue of underfitting, and if we increase lambda, it fix our issue of overfitting or high variance. You will often get to know about high variance and high bias, so be sure to check it out. And also we have a underfitting and overfitting, which is very easy for you to understand. If we decrease our lambda or increase our lambda, decreasing lambda fixes underfitting and increasing lambda fixes overfitting. Adding feature fixes the high bias. And then another thing that I can add here, let me delete this, all those kind of, yeah. Okay, and if I say that adding features, we add polynomial features, we can add a polynomial features. It simply means, let's say theta 1, x 1, 2. Something like that, polynomial features. And it's also form a polynomial like a non-linear curves. Something like this, not this. Okay, something like that. And it forms a polynomial or a non-linear lines. So that's why adding features, getting more training examples fixes overfitting, trying small sets of features fixes high variance, adding features or polynomial features. So let me write here so that you can get the notes here. Polynomial features. And decreasing lambda and increasing lambda. So I think that I give an intuition about the bias and variance concept, which solution is best for whether your model is overfitting and underfitting. And I hope that you will implement this in your real world. And also I'll be implementing these solutions and some of them, and I will be showing up you about overfitting and underfitting, etc. and some of the videos that I will pull out there and the projects for machine learning playlist. So I think that's it. That's the last video of this section, and in the next section we'll start off with a different machine learning algorithm, as this section is very important. So don't don't leave this section. So be sure to check it out, this whole section. Thank you for seeing this video, and I hope that you'll carry out in the next video. Till then, bye bye.